November 20th, 1820. The Pacific Ocean. 0 degrees 40 minutes south latitude, 119 degrees west longitude. 2,000 nautical miles from the coast of South America, which means 2,000 nautical miles from anything. 21-year-old Owen Chase, first mate of the Nantucket whaleship Essex, is standing on deck repairing a damaged whaleboat. The other whaleboats are out. The ship is quiet. He looks up. A large bull sperm whale is lying motionless on the surface, facing the ship. Not fleeing, not sounding, just facing it. Chase watches it begin to swim toward the vessel, picking up speed with shallow dives, accelerating. He orders the helmsman to veer away. The whale hit the ship before the order was out of his mouth. The Essex, 238 tons of oak and iron, shuddered from bow to stern. Then the whale passed under, turned around, and came back. In the account Chase published 4 months after his rescue, he wrote that it returned with twice his ordinary speed of around 24 knots, and it appeared with tenfold fury and vengeance in his aspect. The second impact staved in the bow. The Essex sank that afternoon. 20 men spent 93 days adrift in open whaleboats in the South Pacific. 8 survived. The ordeal included starvation, dehydration, and cannibalism. That event, anchored in Chase's sworn first-hand account, isn't a story about the danger of the sea. It's a story about one specific animal and what it is capable of when pushed. Herman Melville heard the Essex story in 1841 while sailing on the whaling ship Acushnet in forecastle conversations with fellow sailors. Later, in that same voyage, during a mid-ocean meeting with another vessel, he encountered a teenage boy who turned out to be William Henry Chase, Owen Chase's son. The boy went to his sea chest and handed Melville a copy of his father's published narrative. Melville later wrote in his own marginal notes, "The reading of this wondrous story upon the landless sea, and so close to the very latitude of the shipwreck, had a surprising effect upon me." A decade later, Melville published Moby Dick, and in chapter 45 he was careful to assert, in a chapter he titled The Affidavit, that sperm whales sinking ships wasn't a literary invention. He cited documented cases. He insisted the record was real. He was right. On August 20th, 1851, the same year Moby Dick was published, the whaleship Anne Alexander was rammed and sunk by a sperm whale in the South Pacific, a wounded animal. The same pattern as the Essex, 30 years later, different ship, same result. A subsequent report from a Honolulu newspaper noted that when the whale was eventually captured, it was found carrying 2 ships' harpoons embedded in its body. Relics, almost certainly, from the Anne Alexander hunt itself. 2 documented sinkings, both in the same ocean, both by large male sperm whales that had been hunted and turned. Moby Dick isn't a work of pure invention. It's a novel that grew from a specific, documented kind of event, and Melville knew it. But the whale's capacity for that kind of violence is almost a footnote compared to what the animal actually is, what it eats, where it lives, what its body is built to do. A mature male sperm whale averages around 16 meters in length. Some reach 18, and one Soviet whaling record from near the Kuril Islands in 1950 logged a bull at over 20 meters. Typical adult males weigh roughly 40 to 50 metric tons. Picture 9 adult male African elephants stacked onto a single living frame. That is the mass of a mid-sized bull, moving through open water at speed. The lower jaw alone carries 20 to 26 large conical teeth on each side, 40 to 52 total, each one shaped like a thick banana, erupting sometime around age 10, capable of handling prey in total darkness at the bottom of a dive that most mammals couldn't survive. Sperm whales are the largest toothed predators on Earth. Whatever ranked second vanished millions of years ago. Livyatan melvillae, an extinct physeteroid from the Miocene, roughly 12 to 13 million years back, reached similar dimensions and carried teeth up to 36 centimeters long, the largest biting teeth of any known animal excluding tusks. Livyatan had functional teeth in both upper and lower jaws and likely hunted medium-sized baleen whales. It was a different ecological machine than the modern sperm whale, a macroraptorial ambush predator rather than a deep ocean squid specialist. But the lineage these animals descend from has occupied the top of the marine food chain since before most existing species were recognizable. For tens of millions of years, something in this family has been the largest toothed predator in the sea. Right now, that animal is Physeter macrocephalus. The body has been assembled specifically for one environment, the deep ocean at night, which is to say, everywhere below the sunlit surface, which is most of the ocean by volume. Sperm whales routinely dive to depths of 1,000 to 2,000 meters. Instrumented tracking data confirms individual animals reaching approximately 2,250 meters, past 7,300 feet. At 2,000 meters, the pressure is roughly 200 atmospheres. That is 200 times the pressure at the surface, or around 3,000 pounds per square inch, enough to crush any conventional mammalian lung structure. At those depths, there is no sunlight. None. The mesopelagic zone begins at 200 meters, where light fades to near nothing. The bathypelagic zone, which starts at 1,000 meters, is total darkness. These are zones humans have only briefly visited in pressurized submersibles. Sperm whales work them on a single breath. Breath holds extend up to roughly 90 minutes, depending on the dive. One study found their average foraging dives reached approximately 990 meters, with a mean duration of 44 minutes. A Canterbury University research group documented that sperm whales allocate about 75% of their time to deep dives and the intervals between them. Most of the life of this animal is spent in zones that human beings have never directly seen. The physiology that makes this possible is specific and layered. The rib cage is flexible, designed to collapse under increasing pressure rather than trap nitrogen in the lungs, which prevents decompression sickness on ascent. Skeletal muscle carries unusually high concentrations of myoglobin, the oxygen-binding protein, allowing the muscles to store oxygen directly and function long after a terrestrial mammal's reserves would be exhausted. The circulatory system slows the heart rate dramatically during a dive, routing blood to the brain and vital organs while the periphery shuts down. This isn't a general mammalian capability scaled up. It's a suite of specific engineering solutions to a problem most mammals never face. The most extraordinary piece of anatomy, though, isn't in the chest or the circulatory system. It's in the head. The head of a mature male sperm whale occupies approximately 1/3 of the animal's total body length. On a 16-meter bull, that is roughly 5 meters of head, a blunt, rectangular block that looks almost accidental from a distance, as if evolution ran out of ideas. It didn't. Every cubic centimeter of that structure serves a function, and the primary function is sound. The head houses two massive oil-filled compartments, the spermaceti organ and a structure called the junk. According to a 2016 study published in PMC by Panagiotopoulou and colleagues, these two compartments together constitute up to 1/4 of the animal's total body mass. The spermaceti organ, as described in the 1972 NASA technical report by Norris and Harvey, occupies as much as 40% of the entire length of the whale. The fluid inside, the substance 19th century whalers named spermaceti, is a specialized waxy oil that behaves differently at different temperatures and serves as the acoustic medium for the most powerful biological sonar system ever documented. Sound is generated in the nasal complex, passed through the spermaceti organ, reflected off a frontal air sac, and then directed forward through the junk into the water as a highly focused beam. The result is a click. On axis, in the forward beam, these clicks reach source levels measured at up to 236 decibels relative to 1 micropascal at 1 meter. Confirmed by Mole and colleagues in a 2003 Journal of the Acoustical Society of America study that remains the definitive measurement. Their abstract stated plainly, the sound levels measured make sperm whale clicks by far the loudest of sounds recorded from any biological source. Guinness World Records lists sperm whale clicks as the loudest animal sound on Earth, citing that same study at 236 decibels. By comparison, blue whale moans, sometimes claimed as the loudest, reach roughly 188 decibels, a different measurement type in a different frequency range entirely. The click isn't a weapon. Let that distinction land clearly. The idea that sperm whales stun or kill prey with sound was a popular hypothesis for several decades after Norris and Mole first proposed it in 1983. Modern research has rejected it. A 2007 study exposed squid to intense ultrasonic clicks at the loudest levels recorded from toothed whales and found no debilitation, no anti-predator response. Nothing. The sonar is an echolocation instrument, not a sonic cannon. What it does is allow an animal in absolute darkness, 2 kilometers below the surface, to generate a 3-dimensional acoustic map of everything around it. Prey size, range, distance, movement, with a precision that no human technology has matched in biological form. For the animals on the receiving end of that beam, there is no hiding. The system can detect a single squid from extraordinary range. Ink clouds, camouflage, bioluminescent countermeasures, none of it blocks sound returns. The squid's entire defensive toolkit evolved in a visual arms race against animals that hunt by sight. Against a toothed mammal that hunts by sound, it's almost irrelevant. The evidence of what happens at the end of those dives is preserved in sperm whale stomachs, and it's staggering in scale. Researchers have documented individual whales carrying thousands of cephalopod beaks, the only indigestible remnant of a squid meal. These include beaks from colossal squid, Mesonicoteuthis hamiltoni, the largest invertebrate on Earth by mass. The largest colossal squid beak ever found in a sperm whale stomach corresponds to an animal that researchers estimate may have weighed somewhere around 600 to 700 kilograms, though that extrapolation carries real uncertainty. What is certain is that the colossal squid reaches up to 6 meters in total length, carries rotating hooks on its tentacle clubs, has the largest eyes of any living animal, and lives in the same deep southern ocean zones that sperm whales routinely work. It's a genuinely formidable animal. Sperm whale stomachs are full of its beaks. Sperm whales are eating enormous animals, in total darkness, at crushing depth, in volume. The scars are visible on the whales. Circular marks from squid sucker rings cover the skin, evidence that the prey does fight back. The arms race is real and ongoing. It has been ongoing for approximately 20 million years, since the sperm whale lineage settled into deep ocean cephalopod predation as its primary strategy. The squids have hooks and ink and the most sophisticated camouflage in the ocean. They are losing. Now consider what is running this operation. The sperm whale brain is the largest brain on Earth by absolute mass, averaging approximately 8 to 9 kilograms in mature males. That is roughly 5 to 6 times the mass of the human brain. For comparison, the elephant brain weighs approximately 5 kilograms. The sperm whale is at the top of that list by a clear margin, and has been for as long as the lineage has existed in anything close to its modern form. The relative measure, brain-to-body ratio, is unremarkable for a sperm whale. But absolute mass is what matters when you are talking about raw neural processing capacity, and no animal on Earth carries more of it than this one. What does a 9-kilogram brain do in an animal that spends 3/4 of its life hunting in total darkness at depth? Part of the answer is echolocation, The acoustic neural area of the sperm whale brain is dramatically enlarged relative to visual processing areas, an architectural adaptation to a world where sound is the primary sensory medium. Part of the answer is social. Sperm whale society is structured, matrilineal, and culturally complex in ways that continue to surprise researchers. Female sperm whales form stable matrilineal units. Typical groups contain roughly 6 to 12 females and their calves, sometimes forming larger alliances with other units. These groups stay together for life. Males leave as they mature, eventually spending most of their adult years either in bachelor groups or ranging alone through higher latitudes, returning to tropical breeding grounds only to mate. The females and calves are the constant social core, and what they pass between generations isn't just genetic, but behavioral. Sperm whales communicate using rhythmic click patterns called codas. These aren't random, they are culturally transmitted signatures, learned within the matrilineal group and passed down, functioning as acoustic markers of group identity across ocean basins. Different clan dialects exist across the Pacific. A sperm whale born into one unit carries the acoustic fingerprint of that unit for its entire life. Remove the elder females, as commercial whaling did systematically for 2 centuries, and the cultural transmission breaks down. The dialects disappear. The knowledge of foraging grounds, migration corridors, and social bonds accumulated across decades and passed through sound goes silent. One behavioral observation recorded in a 2008 paper by Miller and colleagues in Current Biology changed how researchers understood what the sperm whale does when it's not hunting. Off the Strait of Gibraltar, a team encountered a group of sperm whales hanging vertically in the water, heads just beneath the surface, motionless. The animals were so still that one vessel passed close enough to accidentally bump into them, and they barely reacted. Miller's team confirmed this was sleep, a stereotypical resting posture now documented in multiple ocean basins in which sperm whales drift like vertical pillars just below the surface, largely unresponsive to their environment for periods of roughly 10 to 15 minutes before resuming activity. Sleep time appears to account for a very small fraction of their lives. One study estimated around 7% of recording time was spent in this drift state. The largest brain on Earth, in the largest toothed predator on Earth, sleeps in 10-minute increments, floating vertical in the darkness. There is something genuinely uncanny about that image. An animal built by tens of millions of years of deep ocean predation, with no natural enemy in its home environment, drifting motionless at the surface in a state of near total unconsciousness. For roughly 10 minutes, a 45-ton apex predator is as vulnerable as anything in the sea. Nothing takes advantage of it. The hierarchy of the ocean's large predators is a topic that generates real argument, and the arguments are worth examining carefully because they clarify where the sperm whale actually sits. Orcas are exceptional animals. They are the most behaviorally sophisticated cooperative hunters in the ocean, capable of strategies that require apparent planning, role specialization, and learned technique. Documented orca behaviors include beaching to take sea lions in Patagonia, coordinating wave-washing attacks on ice floes to knock off resting pinnipeds, and, most relevantly, surgically killing great white sharks off the coast of South Africa by inverting them to induce tonic immobility and extracting their livers. That last behavior is precise enough that 2 specific individuals, identified by researchers as port and starboard, have been documented doing it repeatedly and efficiently. Orcas hunt large whales. This is documented. But how they hunt large whales matters enormously, because the method reveals the constraint. A 2001 paper by Pittman and colleagues in Aquatic Mammals documented 3 observed instances of killer whale groups hunting, killing, and consuming sperm whales. In those attacks, adult female killer whales, including some with calves, attacked in waves of 4 to 5 animals in what was apparently a wound and withdraw strategy. The targets in documented attacks are consistently females and calves near the surface. Adult males appear rarely, if at all, in orca predation accounts. partly because adult male sperm whales spend most of their time in high latitudes where orca encounters are less common, but also because the risk calculation changes dramatically with a full-sized bull. A 45-ton animal, even when outnumbered, represents a ramming risk that makes the math of predation very different. The sperm whale defense is the Marguerite formation, described by Mesnick and colleagues as the sperm whales forming a rosette with heads together and tails pointing outward in all directions. Those tails are the primary weapon. Against a tight pod of 7 to 10 orcas, a group of adult female sperm whales in Marguerite formation aren't helpless. They are dangerous. The tails produce enough force to kill. The formation is specifically oriented to prevent orcas from isolating a single individual. Documented orca predation on sperm whales is real, but it is a high-cost, high-coordination operation against suboptimal targets. It isn't the casual dominance that popular ocean hierarchy discussions sometimes imply. The orca's hunting of great white sharks is impressive, and it illustrates exactly where the orca sits relative to the sperm whale. Orcas that have mastered great white hunting are near the top of the accessible ocean hierarchy. What they can't do is range into the bathypelagic zone, hunt colossal squid in darkness at 2,000 meters, or take an adult bull sperm whale without serious risk and significant numbers. The orca is a brilliant shallow water generalist and a specialized pack predator. The sperm whale is something else, the only large predator that genuinely owns the deep. Blue whales are worth a brief mention for context, because the size comparison comes up often. Blue whales are larger, potentially much larger, reaching 30 meters and over 150 metric tons, but they are filter feeders. They pose no competitive predatory threat to sperm whales and occupy a different ecological niche entirely. Orca superpods of 50 to 70 animals have been documented in multi-hour attacks on blue whale calves. Adult blue whales appear to be largely not worth the effort, even for large, coordinated orca groups. The point isn't that sperm whales are larger than blue whales. They aren't. The point is that among all the animals that actually hunt and kill things, the sperm whale is the largest, and has been for longer than most living species have existed. The ruler of the ocean, in terms of toothed predatory supremacy, never evolved gills. Never needed them. This is a mammal, air-breathing, warm-blooded, nursing its young, that outcompeted every gill-breathing rival in the deep ocean and has held that position for millions of years. The physiology that requires it to surface every 90 minutes or so isn't a limitation the ocean has ever successfully exploited. The only thing that came close to ending it was us. Commercial sperm whaling at industrial scale began in the early 18th century, driven by a single product: spermaceti oil, the waxy fluid from the spermaceti organ which burned cleaner and brighter than any other lamp oil available. It lit the streets of European cities. It lubricated precision machinery. Demand for it underwrote entire economies. Nantucket, New Bedford, and dozens of other ports built their wealth on the systematic hunting of the largest toothed predators on Earth. By the 20th century, factory ships enabled hunting at a scale the open boat whalers of Chase's era couldn't have imagined. Population estimates compiled by Hal Whitehead suggest that before commercial whaling began in earnest, the global sperm whale population was approximately 1.1 million individuals, with a 95% confidence interval running from about 672,000 to over 1.5 million. By the time the International Whaling Commission voted to impose a moratorium on commercial whaling in 1982, which took effect in the 1985-86 season, that population had been driven toward a few 100,000. Whitehead's 2022 estimate puts the current global figure at approximately 360,000. That collapse happened in 2 centuries. The sperm whale lineage had been operating in the deep ocean for tens of millions of years before a single human being existed. The industrial fleet nearly ended it in the time it took for electricity to replace the oil lamp. The cultural damage compounds the numerical one. When elder female sperm whales are removed from a matrilineal unit As commercial hunting specifically targeted large, valuable animals, the coda dialects break down. The knowledge encoded in those dialects, accumulated over decades of foraging, migrating, and teaching calves, does not survive without the animals who carry it. Populations can be counted. Dialects can't be reconstructed once the last speakers are gone. Recovery is real, but incomplete. Protected populations have grown since the moratorium. But 360,000 isn't 1.1 million, and the acoustic cultures that existed before the fleets will never be recovered from those that were erased. What remains is the animal doing what it has always done. Somewhere in the deep Pacific right now, a group of female sperm whales is drifting at the surface in the pre-dawn dark, clicking codas between themselves, rhythmic patterns that identify their clan, that have been passed from mother to daughter for generations before any human beings reached the Pacific coast. 1,000 meters below, an adult male is at the bottom of a dive, echolocating in absolute darkness through cold water at 200 atmospheres of pressure, tracking something large and fast-moving that is trying to escape by producing ink in an environment where ink is invisible. Above it, invisible from any human vantage, the largest brain on Earth is building a three-dimensional picture of the deep ocean out of returning sound. The animal surfaces after 45 minutes, breathes, and dives again. It has been doing this since before our species learned fire. Every apex predator that shares its ocean, the orca, the great white, the tiger shark, operates in the upper layers, in the sunlit zones, in environments that are accessible. The deep belongs to the sperm whale alone. It always has.